Hello everyone. Today I'm presenting my project, the Ultimatum Game, AI's Path to Your Partner's Tricky Questions. I'm your presenter, Yan-Chi Guo. So, to build a computer that understands human conversations, we need to incorporate natural language processing methods. It sounds powerful. However, natural language processing itself faces challenges like understanding sarcasm, irony, or contextual speech. So, for example, we have a housewife ask his husband to, peel half the potatoes and then boil them. And this is exactly what the husband did. I mean, he's not wrong, right? But he's still getting yelled at after, you know, his result. And for here, we have this example of sarcasm. A student study 50 hours a week just for him to get flunked. This is surely sarcasm, but the machine couldn't understand it. And also, we have this contextual words and phrases. When you see the picture, you might say, "Oh, this is a fisherman goes to the bank," but the computer itself might come up to this crazy idea. Oh, so the computer might say, "Oh, this is a fisherman. He is going to do some financial stuff in a bank, such as Bank of America, or he's trying to withdraw his savings." But that's probably not right. This should be the bank that related to the water, such as riverbank, right? So in order to help a computer understand human conversations, we need to, break down the sentences. And here we have a philosopher who came up with this idea of logical atomism. And this philosopher is called Ludwig Joseph Wittgenstein. And in this book called The Tumultuous History of the Search for Artificial Intelligence by Daniel Crevier, he summarized Wittgenstein's idea of logical atomism in one beautiful line. And here I quote: "Language, like all other knowledge, can be analyzed, like how scientists did to find out the most basic building block of all matter." And so here we are. We actually developed methods to dice, mince, and blend the language, if you will. And here are the three common methods called stemming, lemmatization, and part-of-speech tagging. And these methods are called tokenization in natural language understanding. And these are very powerful tools so that the machine gets to break down and then understand and ultimately put together a grammatically correct sentence. So after doing the process we mentioned before, we can form biased connections. I mean, bias, I meant like, for example, we're talking about fish. The first thing that might come to mind is water, right? And when we're talking about its motion, it's probably swim instead of run. And when we're talking about apple and its color, like 90% of the time we might think the color is red instead of blue, green, or purple. That would be crazy, right? And when we're thinking about child, the first thing comes to mind might be its parents or father or mother. So we have these bias connections, and they actually carry some certain weights between words. So it actually helps machines to create a more relevant sentence to respond to human conversations. But most of the time, the machine answers might be, irrelevant or seems weird or awkward. So we actually need to use this Bayesian statistics to help us narrow down the most appropriate response. And Bayesian statistics is powerful in these situations because it is recording the prior beliefs, such as when we're flipping coins 10 times. 9 out of 10, we might think, oh, we're getting 50%. That's like we are forming our beliefs using our knowledge, prior knowledge. And computer is doing the same thing, that it is taking account all the prior knowledge we instructed it to do so, and then after each training sessions, it comes closer and closer to the evidence, as you can see in the graph. It's called posterior beliefs, and by training we can actually get to a very close and fine, if you say, um, appropriate response to human conversations. And last, we have a very small pool of conversation using Bayesian statistics, but how do we pick the right amount of details inside this conversation? Well, in my project, I use this game theory called the Ultimatum Game, which is part of the bargaining game inside this theory. And the Ultimatum Game is like a game that has two players, the proposer and the responder. And for the proposer, he is endowed with a sum of prize and tasked with splitting it with the latter. If the responder accepts the proposal, both players receive said prize per the proposal. And if the responder rejects, both of them receive nothing. So hence the name, the Ultimatum Game. So how is this relevant to my project? It is actually an interesting thing. Like when humans interact, we are actually acting differently from other social animals in interactions in an automating game. And this answer is actually leading us to a very ancient but yet beautiful knowledge. It's called the golden ratio. And using this ratio, we can actually formulate an appropriate response to human utterance. And that's how I'm going to build my project. And hopefully this project one day will become a very helpful butler or very useful healthcare giver one day. And thank you. That is my project. I'm Yenchiko. I'm pleased to present this to you today.